Okay, ladies and gentlemen, right, and I'm going to do this this talk. So I'm James Tagg. I'm founder and CTO of Truphone. I'm sorry I can't be there in person, but I think this is sort of a fun experiment in remote working. And I'm here to speak to you about open source communications frameworks. So next slide. Firstly, if you travel internationally, you often end up collecting a lot of SIM cards. It's a real pain. And Truphone sort of solves this problem for you, and we give you one SIM, which is home in many countries, one bill, one voicemail, where we're active in 8 countries where we can give you telephone numbers, and you're in bundle in 66 countries. So our biggest customers are really money center banks who offer services to people around the world. If you look at the behavior of our customers, if you move on to the increased productivity slide, if you look at the behavior of our customers, they generally double their roaming activity, despite the fact that their bill goes down by about a third. So they're very pleased with it. Next slide. And our biggest customers are, I mean, we're basically a B2B play. So we sell to big banks and lots of consulting companies and manufacturing companies and so on. So about 5,000 big corporate customers. Next slide. 2 more. So in order to do this, what we've done is we've built a distributed IP architecture, and that has 2 large data centers, one in London and one in Amsterdam. And then we've actually built out data presence all around the world, so we can keep the data local and keep your voice local, because we don't want to move the voice all the way back to London or Amsterdam if you are in Japan or in America or whatever. And that's a big boon to our customers. We give them a very high quality experience, despite that we're a centralized MNO. So if you look at it from a geographic point of view, we have just a lot of points of presence. So they're distributed all the way around the world. The major ones, obviously in Europe, Australasia and America, but we have smaller points of presence dotted all around the world, giving us local presence. So let me talk to you about open source communication framework. I'm going to advance 2 slides, James, or yeah. So the biggest thing that we're trying to change with open source is that we recognize that much of the innovation that comes out of the world today comes out of developers, and it comes out of developers sitting in front of a laptop, plugging into APIs and putting together new technology and new systems. And there's really traditionally been 2 types of API. There's been person to machine and machine to person. So person to machine, typically you ask a machine, where is my taxi? And it replies, your taxi is on its way. It'll be a few minutes until it's here. And if you look at the other type of API, a shipping company decides that they're going to tell you that your package is arriving, and you'll get a text saying your package is arriving in the next hour or so. And you can often respond to that and say, I'm Terry, so I'm out, and they'll divert the package, and you won't miss the delivery. So that's the kind of common or garden APIs that we see today for telcos. So what we've done is we've built something quite different, and that is a person-to-person API with triggers in it. So effectively what we've got is triggers, or ability to plug in APIs on the outbound side, and ability to plug in triggers, APIs on the inbound side. And so that allows you to create some fairly sophisticated services. So if we look at the sort of things that we've done, I mean, in summary, if you look at the API set, you could build an entire mobile operator out of the API set. So you could sit down in front of your laptop and build everything. I need to ship things. I need to route messages. I'll do something interesting with it that's new and novel. Please pay my taxes for me. Please sort out the billing for me, and do all of the annoying things that the world has developed in terms of know your customer and anti-terrorism and retention of data, and all these hugely intensive and important things that Truphone does, which has taken me, gosh, nearly a decade to build. So all of that can be got at with APIs. And then once you've got at that, you can do interesting things. So let's just talk about some of the things, or the chain. So on the outbound side, obviously, what happens is your handset registers, you authenticate it, you locate the user. I mean, you don't have to locate the user, but a mobile network always knows where its users are. You resolve the numbers. So if I type in 505, that's Truphone's voicemail. We resolve it to a long number. If I type in an arbitrary sort of endpoint, it will go to an endpoint. It could go to a SIP endpoint, and then I can hook the media. We'll talk a little bit more about that in a moment. And on the inbound side, you would have an equivalent set of traps. So again, I can hook the media. It will go to voicemail, but I've hooked the media before it goes to voicemail. So a lot of APIs have this problem that if you hook the media, it's now yours, right? You've got to terminate it. You've got to do everything with it. Well, one of the things you obviously can't do is to drop it back into the customer's voicemail, because you took command of the media. The media is with you if you've pulled it over to a free switch box or a media gateway of some kind. So what we're doing is making sure that although you can hook the media in and out, you haven't hooked it so that you have got no control. So we can then identify it, and then we can deliver it to lots of different places. So we could have it turn up on your desktop as WebRTC, or we could deliver it using either Wi-Fi, either over the top or Wi-Fi calling, or to your cellular. So there's a lot of different ways of hooking and delivering what's coming in towards you. So again, you could build a converged service out of that. So let's look at some of the things that people are doing and some of the fun things that we can do. So the first one is obviously inline translation. So I'm hooking the media, I can hook it out, I can translate it, I can post it back in. So I can build an inline translation service, fairly straightforward. Second thing I could do would be hook the voicemail, and I could transcribe it, or and then I could deliver you a message that says your voicemail contained the following text. So that's another very simple thing to do. Now, of course, we start getting on to the fun stuff. So I can hook the media, and I can apply emotional analysis software to it. So I can tell whether the caller is happy or sad. Now, or all sorts of things, interesting things like maybe lying. So you can have a lie detector on your phone. So you can sort of let your imagination run riot with that sort of idea. An obvious thing you could do with that is in a call center, if someone is getting really irate with one of the call center operatives, you could detect that the call has gone downhill. The person's getting very upset. You could send an SMS to his supervisor and say, you know, there's a problem at booth 3. Why don't you go over and listen over the shoulder? And the guy would walk down and listen over the shoulder and go, okay, yeah, this person has misunderstood. Let's sort of intervene here and try and solve the problem. Another really cool thing you can do is to use identify. So for example, I can have an inbound call, I can work out it's James Bodie. Now that's fairly easy because my phone book's going to do that. But what I actually want to do is I want to pop context. So I've forgotten what I was talking to James about last time. It was obviously something very important, James, sorry. And so I've forgotten what I was talking about. What I'd like to do is I'd like to pop all the relevant documents. I'd like to pop the event information from this, the running order, the latest version of the presentation, the last text message he sent me, you know, and these days I've got them spread all over the thing. So I've got text messages, I've got Skype, I've got GC Bridge, I've got Truphone, IM, I've got just a ton of stuff. So I really want to pop all that context into some sort of display, maybe in a WebRTC view on my laptop. Okay, I'm back, I'm here, I know what's going on. Right, James, what we need to do is this, this, and this. And this context switching problem is one of the, I think, the most interesting problems to solve at the moment. It's something that humans are not very good at, and computers are brilliant at, because the computers remember perfectly. So finally, I mean, let's just talk a little bit about what we do today. So Truphone today already does some quite interesting things with these in-call traps. So we in-call trap the media, and we do it in a very clever way where we actually trap a copy of the media so that we can do work on it in real time without trapping the actual media, which means so if we have to record it in London or transcribe it in London, but the two customers, the two employees of a bank are both in New York, the audio that they're hearing is the audio path that's going New York to New York, whereas we're working on the offline copy of the audio, so we don't have to interrupt the call. So we record calls, and those calls are transcribed, and a certain amount of natural language is applied to it so that people can search for things. Now, I don't know what a bank searches for to find the Forex scandal. If you've actually read the transcripts from the court case, it's just a very bizarre language that they use. But I guess you could, if you know what you're doing, you could pick up things that would mean you should go and listen to that conversation or intervene. And obviously you can do this for text messaging and SMS as well. And then the final thing, and I was going to say this was a future slide, but of course it's not the future because it's now happening, is you insert an AI into the path, into the audio path or the messaging path in real time. You hook it, and now if I was in Lisbon and I couldn't find my way to the conference center, I can shout to the AI and say, AI help. And the AI can say, yeah, Mr. Tagg, how can I help you? So I'm trying to find James Bodie. I'm lost. I don't know where he is. And the AI can locate James, work out where he is, work out where I am, tell me, it knows my orientation, knows I'm facing north. It can say, yeah, basically just walk ahead, turn there in the corner, and you'll find him at the bar talking to Alan Quayle, right? And the AI can do all of that stuff. And that's I thought this slide, I mean, when I wrote this slide a week ago, he lies, obviously I wrote it this morning. When I wrote this slide, I thought this would be a future thing. But of course, with Facebook AM now out and being used, it's current. So this is current technology. So people are putting things in the audio path and doing real-time help. So all of this is very interesting. What's the business model? Well, we always have the over-the-top business model to consider, and certainly Facebook M is definitely an over-the-top business model. But for a telcos are now starting to build these sort of frameworks, network app stores, and I think you've seen, or you will see at the conference, probably 4 or 5 network app stores. At least one I think is actually being launched there. And what they basically are is you create an app. You put it into your account management, just as if you were uploading into the iTunes store if you're a developer. That plugs into the APIs. Now, it's quite important that those APIs are the same for many operators, because if you want to do traps, you want inbound and outbound traps to work, whatever your operator. Obviously, we would like you to be only on Truphone. Thank you. Little plug. But then a network app store gets presented to the user, and the user consumes the app. They pay usually on the mobile operator bill, so it's added to the bill, and then some money is remitted down the chain. And that tends to depend. If the thing that's happening causes more usage for the operator, they're basically happy to just take the money for the usage. If the thing doesn't make money for the operator, or marginal amounts of money, then the operator and the platform developer will take some money out of it. And I guess the Apple App Store set 30% as a sort of typical amount. And so that's really that's where we are with our APIs and the business models for them. And I can take questions if questions work.